Hi, my name is Sebastian Bijawi. This is my free demo on learning target 9D. I'll be demonstrating that I can design FSM counters, synchronous and asynchronous. For my first design process, I decided to go with the synchronous 4-bit 2 counter. I constructed the next state diagram on the right. Very simple, counts by twos. So I've said 2, 4, 6, 8, 10, 12, 14. I then constructed the next state tables from the state diagram and derived the correct Boolean equations using K-maps. We have 4 flip-flops. Now, to test its functionality and logic works, we have a reset, a clock, and to display its outputs, I use a hexadecimal display. For our T1 flip-flop, its input is Q0 prime, so I didn't really use an equation for that. And for our T0 flip-flop, its input will always be 0. So I could connect it to ground, but for this demonstration I decided to use a binary switch. Turn this on and you see it counts by 2, 4, 6, 8, 10, 12, 14. And it is synchronous, so there are no glitches, no delays. As soon as I click reset again, it goes straight back to 0. And this is my 4-bit 2's counter. So for my next example, it's a 3-bit binary 0 to 7 counter that counts up from 0 to 7. Once it hits 7, it goes back to 0 and repeats the same process. Here we have our table for it, 3 bits, Q3, Q2, Q1, decimal 0 through 7, back to 0. Now for its functionality and logic works, I made this circuit using 3 T flip-flops, a clock, and a clear. This is asynchronous, so the Q outputs reroute to the clock. I use a hexadecimal display for easy readability. Ignore this Q4, I just put it in so it would allow me to use the hexadecimal display. As you see here, there are glitches, and this can be mitigated by using a buffer, but I did not add it in this demonstration. But it is counting 0 to 7 and back to 0. And this is my 3-bit binary count up.